Okay, in the last section we talked about the anatomy of lines, and in this section we'll begin our study of the various parts of a line. In this particular section we'll be talking about slope. The slope is identified by the letter M, and there's no particular reason for this. It's just always been there, and we'll continue to use that. The slope is a measure of a line's steepness, and it also tells us which way a line is slanting, to the left or to the right. Now, just suppose I pick any line. So we're going to talk about the visual meaning of a line's slope. So suppose I draw any line, doesn't matter what line it is, and let's add a point onto it, and we'll label it the starting point. And it's easier if we use a letter to identify the point, so we'll use the letter A. And suppose we want to, starting from this point, we'll go up and we'll go up 3 units. 1, 2, 3. And then from that point, we'll move to the right 6 units, which is 1, 2, 3, 4, 5, 6, and we'll label that point again with a circle. We'll call that the ending point, and we'll give it a name, and B seems to be appropriate, so we'll put that. And again, it is 6 units. Okay, and so for this line, the slope is going to be the vertical change divided by the horizontal change, which in this case, okay, if we remember the Cartesian coordinate system, when we move up, it's a positive change. When we move down, it's a negative change. When we move to the left, it's a negative change. And when we move to the right, it's a positive change. That said, okay, the vertical change will be 3, and the horizontal change will be 6. So that means the slope for us is 3, 6. But if we pick any 2 points on the line, the slope should be the same. But in order to accomplish this, we need to have the slope be in reduced form, and 3, 6 is not in reduced form. The reduced form of this fraction is, if you don't know, 1/2. How did I do this? We divide the top by 3 and we divide the bottom by 3. So in moving from point A to point B, the slope is 1/2. Now you may be thinking, well, what happens if I move from point B to point A? Does anything change? Well, maybe it does and maybe it doesn't. Let's take a look. Okay, so we're going to move from point A to point B, and again the slope is defined as the vertical change divided by the horizontal change. Nothing special about that. So starting from B, if we go to the left, we have to move minus 6 units, and then from there we have to go down minus 3 units to get to point A. So the slope is minus 3 divided by minus 6, okay, which is equal to, is it equal to 1/2? Well, of course it is. Why? Well, you're saying, no, it's not. And it's like, well, yeah, it is, because negative divided by negative is what? Positive. And 3, 6 is 1/2. So the slope is indeed 1/2, just like it was before. So whether we move from A to B or whether we move from B to A, it doesn't matter. Now you may be thinking, well, let's say I want to move down from B and then over. Is that going to make a difference? Well, let's check that out. Okay, moving from B to A, moving down from B first, it's minus 3, and then we'll move to the left, minus 6, and so, as you can see, nothing changes. It's still 1/2. So whether we move up from point A first and then go over to B, or whether we go to the right first and then up, or whatever combination you can possibly think of, actually there's only 4 combinations, you will always get the same slope. Okay, so don't ever worry which point you choose as your starting point and which one you choose as your ending point, because it doesn't matter. The slope, when you calculate it, will end up being the same. So for this line that we had here, the slope of this line is 1/2. And of course, this means that no matter what 2 points are on this line that we use to calculate the line slope, the result of the slope will always be 1/2. Now, just to make sure that you're convinced of this, we'll pick A at a different point, and we have B. And instead of going up 3 units, we'll have to go up 4 units. But if we go up 4 units, then we have to go up 8 units to the right to get back onto the line. Okay, well, the vertical change is 4. The horizontal change is 8. And what's 4 divided by 8? Fascinating. It is 1/2. It is, and that's just the way it is. You can pick any 2 points on the line to calculate the slope. Okay, now just to convince you a little bit more, let's suppose I'm at G. Okay, suppose we go down a certain number of units. What's the number of units? It's -5/2. Okay, so what's -5/2? It's -2.5, right? Okay, so remember this. Okay, we're going down -2.5 units. Okay, that's equal to minus the 5/2, which is equal to 5 divided by -2, which is equal to -5 divided by 2. If you don't understand this calculation and why they're equal, please see your teacher. Okay, then from there we're gonna move to the left, and how much are we gonna move? We're gonna move over to the point H, and we're gonna move a distance of 5 units. So the slope is equal to what? It's equal to the vertical change divided by the horizontal change, which is equal to -5/2, okay, divided by -5. Do we need to have the -5/2 in parentheses? Yes, we do, to make things very clear. Okay, we don't want anything to be ambiguous. And then, okay, in order to divide, what do we do with the bottom? We take that number, okay, and we have to flip it, okay. But we don't have a fraction on the bottom, but we can make it a fraction. We can simply divide by -1. And this is equal to -5/2 now multiplied by the reciprocal or inverse of -5, which is 1 divided by -5. The -5s can cancel, okay. But before we do that, do we need the parentheses any longer? No, we don't, because it's no longer ambiguous. It's very clear that it's -5/2 multiplied by 1 divided by -5. So we'll cancel the -5s, and that will leave us with what? 1/2. Okay, just like before. Now, it just happens to be a coincidence that all of these slopes are 1/2. Okay, they could have been something else, and maybe I'll make it something else. But anyway, it's 1/2. Okay, now here's another line. Okay, we'll go up a certain number of places. We'll call it delta y. Okay, and then we're going to move to the right a certain number of places to get back onto the line, and we'll call that delta x. Why delta y? Well, delta y is the vertical change, okay, or the change in the y values, and delta x is the horizontal change, or in other words, the change in the x values of the points, which we'll talk about more about later. So a lot of times we'll talk about the slope as being equal to delta y divided by delta x. It just makes life easier rather than always writing out vertical change divided by horizontal change. It gets to be kind of a very long and cumbersome after a while. Now suppose we have another line, okay, and we'll take this line. And this is a little bit different than the other ones. As you can see, if you remember, the other ones were slanted to the right. Well, this one slants to the left. And in moving from A to B, okay, we'll start out with some point A on the line. I haven't picked my point B yet. That's something I get to choose. And I am choosing to go down 3 units from A. Okay, that means what? We're going down. So the value of, and it's going to be delta y. because delta y is the up and down direction. And so that value is going to be what? Minus 3. Okay. Then we'll go over along the horizontal direction. That is the delta x direction. Okay. That will now give us our point B, which is what we want. And what is delta x? Well, delta x is just, looks like it's 1. So the slope is equal to minus 3 divided by 1. But what's any number divided by 1? It's equal to that number. So in this case, the slope is equal to minus 3. Now, as you can see, for a negative slope, the line slants to the left. Okay, where it seems to be before, all the slopes were positive and they were slanting to the right. And that happens to be a true statement. When the slope is negative, it will always slant to the left. And whenever the slope is positive, it will always slant to the right. Now, suppose I want to move from point B to point A. Well, then, is our delta x going to be 1? No. Our delta x is going to be minus 1. And our delta y, is that going to be minus 3? No, because we move upwards. And so it's going to be a positive 3. So the slope is equal to still 3 divided by minus 1, which is equal to minus 3. And again, remember, since for negative slopes, the line slants to the left. So if by chance you happen to ever have a problem and the graph is slanting to the left, but the slope is positive, you know something is wrong. It is not right. Either the slope value that you calculated is wrong, or the graph would be wrong. And now, here's some problems that you just might want to look at. In these figures, the delta x value, in other words, the change in the horizontal change, is for figure 1, for figure 2, and for figure 3, it's all the same. Its value is 5. But the vertical change increases as we go from figure 1 to figure 2 to figure 3. And notice that the slope of figure 1 is less than the slope of figure 2, which is less than the slope of figure 3. And not only that, the steepness of the line of figure 1 is not as steep as figure 2. And the figure 2's is not as steep as figure 3. So what I'm saying is the slope increases from figure 1 to figure 3. And so does the steepness of the line. They are related somehow. And like the positives, we also have the negative slopes. Okay. And take a moment here, just a moment. Okay, so an observation that we have is that all the lines above has positive slopes and all the lines slant to the right. And for negative slopes, okay, the lines, you can see as the line gets steeper and steeper, so to speak, slanting, the line is getting more vertical, okay, the slope is getting smaller and smaller. So in other words, as we move away, if the slope is negative, the further away we get from the slope being 0, the steeper the line. Okay, and as you can see, all of the lines above have negative slope, and all of the lines slant to the left, which is what we would expect. Okay, and we'll end the show here. Okay.